Hi, welcome to Block 2, Developing Geometric Reasoning, Lesson 9. I'll share my screen. So, in your previous lesson, you learned how to use knowledge of the sum of angles in different polygons to solve interesting maths problems. In today's lesson, you're going to learn by investigating angles in parallel lines. Remember to like the video, share the video with those you think can benefit, subscribe to the channel, and click on the notification bell so that when new videos are released, you will be notified. Thank you. Before we start, I would like you to pause video and answer these retrieval practice questions in 3 minutes. Assuming you've paused the video and you've answered the retrieval practice questions, let's review the answers. For question 1, you were simply asked whether the lines are parallel. No. These lines, if we continue to draw these lines, they will meet, so they're not parallel. Next, you were asked to state the size of each angle. This exercise is meant to help you recall how to identify and label angles correctly. Notice how the middle letter tells you the position of the angle. So A, B, C should be 48. So the middle letter B is telling us that we're looking at angle 48 degrees. DCB. Notice how the middle letter tells us the location of the angle. So the letter C tells us that we are after angle 41 degrees. And angle ADE means we're looking for this angle here. Now, you must recall from our previous lesson that these are vertically opposite angles. So angle ADE must also be 81 degrees. All right, let's do some new learning for today's lesson. What does it mean for two lines to be parallel? Well, it means the lines will never meet. So parallel lines never meet. So we're going to look at some parallel lines using this grid. Here is our first one. So if we continue to draw these lines, even in an extended grid, the lines will not meet. Here is another pair of parallel lines. So parallel lines do not have to be horizontal or vertical. They could be in, on the line on the side like this. And here is another one. Now we use these arrow notations to show parallel lines. So we use different arrow notations to show the same parallel lines. If we have more than one of them in a particular, page, we can use a different arrow notation to show those pair of parallel lines and a different one to show those pair of parallel lines. And of course, we can have parallel lines on plain sheet. So we can have it on a non-grid paper, so paper that is not showing any grid. And these are parallel lines. And here they are as well. So we have talked about parallel line segments. So I missed using the word segments. But now, if we talk about just parallel lines, it means lines that can be infinite. Okay? So these lines are just parallel lines, they're infinite. But these lines I have been talking about are parallel line segments. So the correct way to name these are line segments. So line segments have a specific definite length. They just don't continue forever. But these, we can just call them parallel lines, these ones, okay? Because they go infinitely. Okay, if you're asked to draw a line segment parallel to PQ, how can we do this? Well, we can mark a point on PQ, on the line segment PQ. We take a protractor, make sure the crosshairs of the protractor lines up with the point we marked on the line segment PQ. Mark a point above the 90-degree line on this protractor, and then mark another point on line segment PQ, and then take the protractor and do the same like we did for the other point. Mark a point above the 90-degree point. Then we can take a ruler and join those 2 points with a line segment. So we have just drawn a line that is parallel to line segment PQ. Can you think of any other ways of doing this? Well, there is. We can use set square to draw parallel line segments. So if we want to draw a parallel line segment, we can place a ruler and then position a set square on top of the ruler. Then we can use the slant side of the set square to draw one of the parallel lines. And then we can slide the set square along to any point we wish to draw the other parallel line, and then draw the parallel line. We have just produced, using a ruler and a set square, parallel lines. Of course, I forget using the word line segments, okay? So these are parallel line segments because they do not continue infinitely. They have definite length. And of course, do not forget to include the parallel line notation on the line segments. And we do not always have to have our ruler in a horizontal or vertical position. It can be slanted. The process would still work. So if we position our set square on top of the ruler, if we draw the parallel line, one of the parallel line segments, we can slide the set square along the ruler and draw the other parallel line segment. And we can include our parallel line notation. What if we have a question like this? We've been asked to draw a line segment parallel to PQ through point A. So we have to draw a line that is parallel to PQ, and that line has to pass through point A. Well, one of the ways of doing this is we can gently slide our ruler. So we make sure our ruler doesn't move, and then we gently slide it along until we get to point A. And then we can draw our parallel line segment. But something is missing, isn't it? We have not included the parallel line notation. We could also know, we should know that this isn't perfect, because who knows how much your hand would have moved or slightly, so you may not have a really good or effective parallel line that is parallel line segment that is parallel to line PQ and that passes through point A. So let's see how we could use a ruler and a set square to make it much better. So we're going to use a ruler and a set square to draw a line that is parallel to a given line segment AB and passes through a given point P. It is similar to this question, and the orientation has changed. But using a ruler and a set square, we can make it much more precise. I want you to have a think how you would do this. Let's proceed. Step 1, you would place your set square on line segment AB, the line that was already given to you. Next, you would position a ruler on the side of the set square like this. Next, you would slide the set square along so that you have the side of the set square line up with the point P where the other parallel line segment has to pass through. Next, you draw a line through that point P and you use a ruler to complete the point P if you wish to complete the line that passes through point P if you wish to extend the line further. Okay, here we have a parallel line segments AB and CD. If we draw are these line segments AB and CD parallel? Yes, of course they are. Now, how do we know? How do we know that they're parallel? Well, we know that they are parallel if we see those notations. So before those notations were included, we could not say that they are parallel. But when we see those notations, we know that those lines are parallel. Now, if we draw a line like this, do you know what this line is called when we draw a line that cuts through a pair of parallel lines or several pairs of parallel lines? We call that line transversal. So this is a very important word we're going to be using. So do not forget this word, transversal. Transversal simply means cuts through. So we can say, if we want to read this, we can say line EF transverses through parallel lines AB and CD. So EF is a transversal that cuts through AB and CD. GH is a transversal that cuts through lines AB and CD. And these are other transversals. It's now time for you to pause the video and practice what you've learned. Pause the video and answer question 1 in 2 minutes. Assuming you've paused the video and you've answered question 1, here are the answers. Let's discuss them. For question 1, you were asked for each diagram, draw a line segment that is parallel to AB and goes through point C. Now, you have learned how to do this using a ruler and a set square. Or you could use the other simpler method which we use but would not give you a precise result by just placing your ruler on A, B, and then sliding the ruler gently till you get to the point C, and then you draw a line segment parallel to the lines that you wish to reproduce. And of course, you wouldn't forget to put the parallel line notations. Pause the video and answer question 2 in 2 minutes. Assuming you've paused the video and you've answered question 2, here are the answers. Let's discuss them. Here you were asked, draw a transversal that cuts through the parallel lines and goes through point R. All you have to do is to take a ruler, Make sure the ruler is lined properly and goes through point arrow and just draw a straight line. So the transversal can be at any angle when you draw transversals to parallel lines, but in this case, you've been told it has to go through point R. Let's do some new learning. Line segments AB and CD are parallel. EF is a transversal that cuts through AB and CD at points G and H respectively. We've been asked to draw a diagram to represent this. Have a think. Would you be able to do this? Of course, I'm sure you would have had a think, and I'm sure you'll be able to do this, but let's see the example. First, you draw the line AB. You draw the line segment AB. Next, you draw a parallel line CD that is parallel to AB. Make sure you include your parallel line notations. And then next, you draw a transversal. And then you mark the points G and H on the transversal. So the transversal can take any orientation. It can be in that orientation or the first orientation. And of course, you mark the points through which the line segment, the transversal line segment cuts through the parallel lines AB and CD. And of course, you do not forget to put your parallel line notation. And it can be in any orientation. Okay. When you look at this transversal that cuts through parallel line segments AB and CD, what do you think the angles A, G, H would be compared to B, H, D? So our angle A, G, F and D, H, E the same? Of course they are. If you measure them, you would notice that they are both 95 degrees. So we say that AGF and DHE are alternate angles. And one thing you need to know, another fact, geometric fact you need to know is alternate angles are equal. Alternate angles are equal. There is something I want you to really take note of on how to spot sometimes alternate angles, because I would ask you to pause the video and see whether you'll be able to spot some alternate angles. Watch me draw this shape and see how it connects these alternate angles. Do you see that it looks like a Z shape that looks like this? And the angles are in the same position in the Z shape. So something you should note is that alternate angles are connected with an invisible Z shape. If you look really well, you can spot them. Are there any alternate angles you have noticed? What about this one? Angles BGF and DHF are both 85 degrees. Again, notice how the middle letter tells us the position of the angle we are interested in. Angle BGF. BGF. and angle DHF. They are both 85 degrees. But this time, we'll notice something interesting and different. So we say that BGF and DHF are corresponding angles. So remember the first one you learned about alternate angles. And you notice that you can see an invisible Z shape that connects the angles that we are calling alternate. And then we find these in parallel lines that have transversal cutting through those parallel lines. Now, if you look at these, we say corresponding angles are equal. So take note of another geometric fact that you would use. Corresponding angles are equal. I want you to take note of this. Have you noticed this shape when you look at this? So we have an F shape and the angle is in the same location of an F shape. So if we have something like this, the angle is here. Okay? So we say corresponding angles are equal. So note the ones we call corresponding and note the ones we call alternate angles. I'm sure you would have found some other corresponding angles within this shape. Sometimes the orientation could be different. It could be upside down. It's now time for you to pause the video and answer some questions to practice what you've learned. Pause the video and answer question 3 in 2 minutes. Assuming you've paused the video and you've answered question 3, here are the answers. Let's discuss them. For question 3, you were asked line segments AB and CD are parallel. Line segment EF is a transversal that intersects the line segments at points X and Y respectively. Measure the size of each angle. So imagine you had the worksheet or you had paused the video and took a screenshot to print the worksheet before doing the lesson. You would notice that these are the angles. And then next you were asked to complete the sentences. You would notice that angle AXE is alternate to angle DYF. So angle AXE. So here is alternate to DYF. This angle here. And have you noticed how they are connected by a Z shape? Okay, so we say it's alternate. And then we have, so I'm going to have to rub it off each time. Just a minute, let's get the pen to be stable. All right, next, angle AXE is corresponding to angle CYF. Angle AXE, this angle, AXE is corresponding to CYF. So CYF. Sorry, CYE. Yeah. Have you noticed? Have you noticed the shape that you see here? The F shape that is in reverse, but look, the location of the angle is in the same location on the F shape. So imagine an F shape that looks like this, and the angle is in the same similar position in on the F shape. So we call that corresponding angle. So F shapes help us identify corresponding angles, and Z shapes help us identify alternate angles. So let's rub this off. Angle, let's get a pen. Angle BXF, so BXF. So remember, the middle letter tells you where the angle is, BXF. So it should be here. Is corresponding to angle DYF. So DYF. So it should be this angle. And you can see the F shape that connects them right there. So F shapes help us identify corresponding angles. So if you can imagine or visualize the F shapes and you see angles in the same locations of those F shapes, those are corresponding angles. Okay, let's look at the other one. Rub this off first. Angle CYF, angle CYF, angle CYF. So it should be this angle. Is alternate. So angle CYF is alternate to angle BXE. So let's say, I think it's BXE. So it's that one. Okay. All right. So let's move forward. All right. Pause video and answer question 4 in 2 minutes. Assuming you've paused the video and you've answered question 4, here are the answers. Let's discuss them. For question 4, you were asked, 4A, you were asked, given this question, you were asked to draw a diagram to represent that. So yours could look like this. For some other people, the orientation could be, the transversal could be in that direction. And here is the answer to B. So you were asked, each angles are formed, measure the size of each angle and label them on the diagram, compare answers with a partner. So this is if you're studying in a group. Then for C, you were asked to identify 2 pairs of alternate angles and 2 pairs of corresponding angles. So by now, you know how to identify alternate angles, visualizing the Z shape on the shape, and then looking at where the angles are in the Z shape, we should be in similar locations. And then you have identified how to use the F shape, visualize the F shape to help you identify corresponding angles. And these are some examples you could get. Pause the video and answer question 5 in 3 minutes. Assuming you've paused the video and you've answered question 5, here are the answers. Let's discuss them. So for question 5, you were asked, complete the sentence in 2 ways. Line segments OB and PB are parallel. So line segments OB, OD and PB Where is PB? Yeah, they are parallel. All right, and you can see the parallel line notations. And then here is the other statements. All right, so you were simply, going to look for, things in the diagram to complete the statements. And of course, the other one would be CF and KN. Next, you were asked to complete the sentence GJ is a transversal. Yeah, so GJ is a transversal that intersect the line segments OA and PB. And of course, you could extend it at which points did they intersect the line segments. You can say H and I. And here are the answers for questions C, D, and E. So here you were asked to identify 4 pairs of alternate angles. So by now, you know how to identify alternate angles and corresponding angles. And that is what your answer could be. Next, you were asked that angles GHO, angle GHO, GHO, and ALN are alternate angles. Of course, it's not. So by now, you know how to identify alternate and corresponding angles. So they are not alternate angles. So she's wrong. And that brings us to the end of our lesson. So in this lesson, you have learned how to investigate angles in parallel lines, and then you've used that knowledge to be able to identify keywords, to learn about keywords in this lesson. You've learned about the word transversal. Transversal is the line that cuts through the parallel line. And once you have transversal, you can be transversal for parallel lines. You can then identify corresponding and alternate angles. We also learned that visualizing the Z shape and looking at angles that are in similar locations of the Z shape helps you identify alternate angles. And then visualizing the F shape and identify angles that are in similar locations of the F shape help you identify corresponding angles. Well done for taking your learning seriously. Until next time, take good care of yourself and bye-bye.